Happy Monday, everybody. Welcome back to Algebra 1. Hope you guys had a great weekend. It was beautiful weather. Hope you had a chance to get out inside and enjoy it a little bit. Today, we're continuing Chapter 8 with continuing with factoring and introducing a couple special cases and kind of building off what we talked about last week, Thursday. So a couple of quick announcements. First, we got a homework collection this week. Last week, we did not have one, though we did have a formative quiz. Number 12, again, I think there's only like 3 or 4 weeks left of school. I think single digit days that we actually have left of new instruction in Algebra 1. So if you are missing stuff, tests, quizzes, whatever it might be, getting that stuff turned in because, again, we are quickly running out of time this school year. We are under a month to go. So, again, it's time to start chipping away at some of that missing work if we have any of that. So, last thing I want to touch on for announcements, we do have a option or opportunity for a Chapter 7 retake. So if you didn't like what you got on the Chapter 7 test from last week, you can do a retake on that test if and only if you have all your homework done from Chapter 7 and you meet with your grading teacher before you take the test. So you can go over that the test you took last week, talk about what you did wrong, then we'll give you the password so you can do the retake. And again, you can only retake it if you meet with your teacher and you have all of the Chapter 7 homework done. So, again, if you are interested in doing that, send your grading teacher an email, talk to them after class, whatever you got to do, but get on it, again, because we are quickly running out of time. So, again, today, I'm going to flash the answers up for the homework very quickly, so let's do that. Here we go. Otherwise, check the filled-in notes for these in a little more detail. There we go. So, let's see here. First thing I want to talk about is doing a little review for our diamond problems, just to get us warmed up, thinking about math again after a nice weekend. So with our diamond problems, again, we've got the thing on the bottom, or the number on the bottom, is negative 5x. So these two empty boxes have to add together to get this bottom box. These two things on the side have to multiply together to get to the thing on the top. So what I like to do is just to think of multiples or all the multiples of negative 24 and then figure out which ones could potentially add up to negative 5. So let's think of things that multiply together to get 24. So if we have like 1 and 24, we have 2 and 12. I think we have 3 and 8, and I think 4 and 6 are the only multiples of 24. So let's go through and see if we can figure out something that might add up to 5. Negative 5. So 4 and 6, add those together, we get 10. Subtract them, we only get 2, so that's out. Let's see here, 1 and 24, that's definitely not going to get close enough. 2 and 12, we can either get to 10 or 14, depending on how we are adding or subtracting those. So I think we got to go with 3 and 8 for the two multiples of 24 that could add up to negative 5, or negative 24 add up to negative 5. So we have 3x and 5x. Like on the left and the right. Again, we have to attach the x because x times x is x squared. So now we just got to figure out which one needs to be, not 3 and 5. That has to be 3 and 8. So let's fix this. There we go. 3 and 8. All right. So now we got to figure out which one's supposed to be positive, which one's supposed to be negative. So we know because our multiplication term at the top there is negative that one of these two has to be negative. One of these two has to be negative. So again, knowing that we've got these two numbers add together to get negative 5x, I think we have to put the negative out in front of in front of 8, because then when we add 3 to that, we get to negative 5. 3 times negative 8 is negative 24, and we are all set. Again, we use these to help us factor quadratics and trinomials, which, again, is what we're going to continue doing today. So let's jump into 813 and work through a couple of these together just to get our memories jogged from what we talked about last week. Thursday. All right, so we want to factor each quadratic expression below if possible. Again, not necessarily possible. So there is one of these 4 and 824 that is not possible, but I'm going to walk us through the first two just so we can review a little bit. So let's start with part A. So we have x squared plus 6x plus 9. And we talked about on Thursday last week that we know two boxes of our generic rectangle right off the bat, because we can just plug in the x squared term and the number at the end into the bottom left and the top right part of our generic rectangle respectively. So the squared term always goes bottom left, the number at the back always goes in the top right, and now we just got to figure out what these two empty boxes are. So we also talked about last week how the product of the two diagonals, so if we take these two empty boxes, multiply them together, we get the same thing if we multiply 9 and x squared together. So that's how we can use that relationship to figure out what these two empty boxes are. So if we take these two terms, multiply them together, we get 9x squared. And that always goes in the top part of our diamond problem. So the other thing that we can fill in with our diamond problem is this 6x. So we know that these two boxes that are currently blank, we'll fill those in just a second. Again, they multiply to 9x, but they add to 6x. Sorry, they multiply to 9x squared, but they add to 6x. So this 6x goes at the bottom of our diamond problem. So now we need to think about multiples of 9 that add to 6. So let's list our multiples of 9. We've got 1 and 9, and then 3 and 3. So 1 and 9 is not going to add to 6, but 3 and 3 does. So our left and right boxes are 3x and then 3x. So when we add these two together, we get 6x. Multiply them, we get 9x squared. And again, these two side boxes, go on, or go into the same exact spots, or those are the blank. Sorry, those are the blank parts of our generic rectangle, and we just got to move those over and finish up our problem. So we got 3x and 3x. Great, so now we can get to work labeling the side length, the length and the width of our generic rectangle, which is going to tell us the factored form of this quadratic. So we have x squared, 3x, 9, and 3x. So let's start at the bottom left. We have x squared here. And I think there's only one combination of things that we can get to multiply together that get us to x squared, and that would be x times x. So it means on either side of this, we got to put an x and an x. So now if we go up, we have what multiplied by x gets us to 3x. This has to be 3. Again, what multiplied by x gets us to 3x here, again, has to be 3. And then 3 times 3 does, in fact, get us to 9. So we did factor this correctly. So our final answer is going to be x plus 3 times x plus 3 for the factored form of that quadratic. But we can take this one step further, because this is the exact same thing multiplied by itself twice. So I'm going to simplify this one more time and say it's x plus 3 quantity squared. Okay, so it's the same thing multiplied by itself twice, which is why we can say that, and that is equal to x squared plus 6x plus 9. Great, so that's how we do it generically. Again, we can do the same thing with b. Again, the 2x squared goes in the bottom left of our rectangle. The 3 would go in the top right. I'm going to leave b and d for you to do on your own for 24, so check the filled in notes for those solutions in just a little bit. But I'm going to work through c together, because again, these are not always factorable. And I'm going to show you why c does not factor. So again, let's take the two terms that we know for sure, or the spots for those for sure, put those in our generic rectangle. So we've got x squared in the bottom left. We've got -7 in the top right. So we know again that the two missing boxes here are represented by this two side parts of our diamond problem. So these two, or those two sets of boxes, go in those respective places. So those two things multiply together to get the product of these two things, which is -7 times x squared. So this has to be -7x squared. And again, they add up to be 5x. Add up to be 5x. Perfect. So now we just got to figure out what are some multiples of 7 that add to 5. Multiples of -7 that add to 5. So the only ones that I know would be 1 and 7, where one of those two numbers is negative, because 7 is a prime number. So are we ever going to be able to add any combination of either a positive or -1 to a positive or -7 to get 5? Absolutely not, right? Because either we could get 7, or we'd get 8 or 6. and that's not 5. So this is not factorable. Not factorable for part C. Perfect. So again, do B and C on your own. So take a look at the filled in notes for those solutions, and we're going to keep moving for the video here. So let's go to 825 next. Now we got some special cases. So most quadratic expressions are in the form of ax squared plus bx plus c. But what if a term is missing, or what if they're in a different order? So we're going to take a look at a couple of these cases and see if we still can't use the same exact method to still factor these different quadratic expressions. So let's start with 9x squared minus 4. So the first thing I'm going to do here is I'm going to rewrite this, because again, we have an x squared term, we have the constant at the end, but we're missing that bx term in the middle of that generic form. So what this is really saying is it's like 9x squared plus 0x minus 4. And that should help us fill out our rectangle and our diamond respectively. So let's plug in the things that we know. Again, we've got 9x squared. We got negative 4 here. So these two things together, those two missing boxes in our rectangle, have to add to 0x. So this in our diamond problem have to add to 0x. Or just 0, but I'm going to leave that x in there. So next, what we have to do is figure out what they multiply to. And again, it's the product of the two filled in boxes. So it's negative 4 times 9x squared, which is negative 36x squared. Great, so now we got to think of multiples of 36 that could potentially cancel out. So let's list some multiples of 36. I'm just going to throw a couple of them out there. We've got like 1 and 36. That's not going to help us. 2 and 18. We've got 4 and 9. There is one for 3. I'm skipping it. And I think we have 6 and 6, right? Because 36 is a perfect square. We don't need, it's not a perfect square in this case because it is negative. But let's use 6 and 6. So if I plug 6x here and 6x here, again, we know that it's negative 36. So one of these two has to be negative. There we go. So let's make one of those negatives. So when we add 6x and negative 6x, we get 0 x's. Multiply them together, we get negative 36x squared. So that is what has to go in our two boxes over here. So let's say 6x up on top. Let's do negative 6x in the bottom right. Perfect. And now what we can do is work on factoring this, finding the length and the width. So all right, so when we do this, now we got to think about different multiples of things that'll get us to, again, negative 4 up on the top, 9x squared in the bottom right. So here we need multiples of 9. So I'm going to try it with 3x. So if we do 3x times 3x, we multiply those together, then we get 9x squared. So if we multiply, so now another way we can check this is if we, whatever we put here, if we can multiply this number by something to get to the green numbers on either the ones that we filled in from our diamond problem, then we know that we probably have the right term in each respective spot. So if this is a multiple of whatever this number is, then we are in good shape. So now we just got to multiply 3x by 2 to get to 6x. So I'm going to put a 2 right here. We have to take 3x, multiply it by negative 2 to get to negative 6x. And now if we multiply 2 and negative 2, we get negative 4. So the final answer, 3x minus 2 times 3x plus 2 is equal to 9x squared minus 4. Perfect. So now let's go to part B. Again, we can use the exact same method. We have this generic form up at the top part of the page. I'm going to use that and just add a 0 for the term that's missing. So we have the x squared term, we have the x term, we are missing the 0 term at the end. So I'm just going to put plus 0. Perfect. So again, let's put what we know. Okay, so this 12x squared has to go bottom left. 0 has to go in the bottom right. So now if we find what, and then, sorry, I forgot. So these two side boxes on our diamond pattern, or the two missing boxes, have to add to negative 16x. So negative 16x has to go here. Negative 16x has to go here. And then we know that they multiply to 0. Because again, if we take the product of our diagonals here, 12x squared times 0 is 0, because anything times 0 is 0. So now we have to say what two things add together to get to negative 16x, but multiply together to get 0. So if we're multiplying to get to 0, one of these numbers has to be 0, because 0 times anything is always 0, which means this other box is going to be negative 16x. Perfect. So now let's plug in what we learned here. So we have a 0, and then we have a negative 16x. Perfect. So now we just got to think multiples of 12 for this bottom left part. That would multiply together to get 12x squared, but also could multiply into negative 16. So multiples of 12, we've got 1 and 12, 2 and 6, 3 and 4. 2 and 6 potentially could work, but I think we can use 3 and 4 instead. So let's use 3 and 4. So we know 4 is a multiple of 16, so I'm going to put the 4 on the left-hand side. I'm also going to put then the 3 on the bottom. So we have an x squared term. So we have an x squared term there. So both of these terms have to have an x. And then 4x times what gets us to negative 16x? This has to be a negative 4. So now this top row is all zeros, so that just has to be a 0. So we can finally have our factored form written out as 4x times 3x minus 4, again, is equal to 12x squared minus 16x. Perfect. It's the same exact thing. Again, what I would just recommend is if we're missing a term like we were here, just put a 0 in its place so we can put the stuff in the right spots that we need to for our pattern. And we should be able to follow that pattern through from there. All right. So I'm going to have you do, if you turn the page, C and D. Take a look at these on your own. Again, find the term that we're missing and then just add a 0 for that term. For part C, I would recommend rearranging this one before you get to work. So we'll make sure we're putting the right things in the right spot. So the x squared term goes first, because remember it is ax squared plus bx plus c is that regular form that we've been kind of used to seeing. So make sure it looks like this before we try to factor. And then same thing for 26 and 27. So 26, what I want you to do is, again, find the factored form of this one. There might be more than one opportunity or more than one answer for this one. Check the filled in notes for the solution for this. If you have any questions on that one, again, because there could be 2 solutions, we'll have both of them in there for you, but feel free to double check those. And then last but not least, 27 is really a challenge. It's a fun problem. But now, again, what we got to do, we want to fill in this rectangle. We want to fill in this rectangle, and we want to find these missing blanks. And to do that, we have to multiply the length and the width for the respective boxes. So like for this box, it would be the product of x plus 7 times the product of x minus 2. And then we can use the length and the width for these respective boxes to factor, let's say, like 3x squared minus 5x minus 2. So we can make this one of our diamond problems to find the lower left-hand side, which is this one right here. This is what I'm kind of setting up for us. So if we want to find that one, we're trying to factor this. We know one side of that is x minus 2. So if we use x minus 2 here, we can use our generic rectangle to factor this, knowing already one side. Kind of a fun problem. So take a look at this one too. We'll put the solutions in there for everybody. Other than that, the last thing for today is just that the homework is 8.1.3, the next section in that pink packet. If you have any questions or want to retake that test, make sure you reach out to your grading teacher. Other than that, hope you guys have a great rest of your Monday. Look forward to seeing you all in live class tomorrow.